Okay, so the plan today is to talk about surface area of prisms, okay? Now, I asked you to have 3 different colors because it's going to be easier for us to do some of these problems if we can kind of trace what we're looking at. I think you guys will be able to see it better. So let's look at the first slide here. It says surface area is the sum of the areas of all the surfaces of a figure. Okay, so when I talk about surface area, if I'm thinking of this room, we already know the volume is like the air inside the room. The surface area is like the paint on the walls, and the carpet on the floor, and the tiles on the ceiling. That's all the surface area. Okay? Or it's like if you took a box and you put wrapping paper around it. You're covering the surface of the box. Okay, we're talking about surface area. Now, there's a formula. I never knew there was a formula for surface area until the MCA started. I'm going to give you this weird formula. And this formula right here is on the MCA test. I think it's the oddest formula ever. Okay, it says surface area S equals 2 capital B plus pH. Apparently, you're just supposed to know what that all means. Okay? Well, I can tell you what it means. It means 2 times the area of the base plus the perimeter times the height. That's disastrous. I don't really know why anybody would do it that way, because that seems like a lot of random work to do. It's much easier to just think of it as all the surfaces. Okay? So we're going to ignore the fact that there's this formula, and we're going to look at it this way. Okay, if I take this prism, and I were to open it up, what shapes is this made out of? Really? Okay, right, everybody agree? Okay, so let me open it without breaking it. Right? All we have is a bunch of squares, or 2 squares in this case, and 4 rectangles. Do we know how to find the area of a rectangle? That's easy, right? Base times height. Do we know how to find the area of a square? That's easy too. Base times height. So instead of trying to deal with this formula that I think is kind of messy, we're just going to find the area of everyone and add them together. That's way easier. Okay? If we have a triangular prism, what shapes make up this prism? Really? Rectangles and triangles. Agreed? This one's harder to get apart. Okay, so we've got a rectangle, a triangle, a rectangle, and a triangle. Do you guys know what these are called when they're opened up like this? We probably had to do this before. These are called nets. Okay, when you have to draw a net of an object, of a 3-dimensional object, it really means you're just laying it flat. These are nets. Okay, we're not going to really worry about drawing nets, but I need you to understand what shapes make up the object. Okay, so what we're going to do today, we're going to ignore the formula. Okay, and I'm going to show you a different way to do it. Okay, so starting with this one, it says find the surface area of this triangular prism. Okay, and we know that this triangular prism, did you have your notes back there? You absolutely need to have this in front of you. So. Okay, so let's start by listing what we have. What shapes do we have here? Triangles and rectangles. Okay. How many triangles are there? Caleb. 2. Are the triangles exactly the same? Yeah, remember in a triangular prism they have to be, right? Because the triangles make up the bases, so they have to be identical. Okay? Are the rectangles all the same? No, not necessarily. Okay, they are the same like in this one, because the triangle was an equilateral triangle. Okay? But they don't necessarily have to be the same. So here's what we're gonna write. We have triangles times 2. There's 2 of them. And then I'm gonna write R1, R2, and R3 for rectangles. We have 3 rectangles. Okay? So I want you to take one of your colored pencils. I don't care which one. Pick a color. And I want you to outline the triangle. Just the triangle. Okay, and I like using colors on this because then we can just focus on that one piece. So I need to start by finding the area of that triangle. How do I find the area of that triangle? What do we do, Caleb?
Base times height divided by 2.
Absolutely. Base times height divided by 2. What's the base and the height of the triangle? Brooklyn?
The base is 8, and then the height is 3.
8 times 3 divided by 2 is 12. That's one triangle. How many triangles do we have? 2 of them. So what do I have to do to that number? Caleb. Times it by 2. Okay, so the triangles is 24. Everybody agree with that? Okay, grab a different color. Okay, and let's outline this bottom rectangle. What are the measurements on that pink rectangle in my case? What are the measurements there? 8 times 10, right? This side is 8. This side is 10. So we would do 8 times 10 is 80. Okay, I'm going to switch colors. And let's do this one on the back side here. So this rectangle on the back. What are the measurements on that rectangle? In my case, it's orange. What are the measurements there? Krista? 5 times 10, which is 50. And then we have one more rectangle, which is this one on the front. Okay, so I put that in a different color, and maybe you just have to use your pencil. Okay, I don't think we'll take all 3 colors. What measurements are on that side rectangle there? 5 and 10 again. 5 times 10 is 50. Okay, now we've got these 4 numbers, 24, 80, 50, and 50. We just have to add them all together. Okay, to find the surface area, you add the area of all the surfaces. So 24 plus 80 plus 50 plus 50. You get 204. How would I label that? What do you think? 204 what? Feet? What though? Go ahead.
Feet like units?
Feet, but so remember we've had feet squared, we'd have feet cubed, we've had, what would this be? Feet what? It's area, so it's feet squared. Okay, because we're just covering it, so 204 feet squared. Okay, now do I expect you to always do different colors? No. But for some of you, that might help you see what you're looking at, okay? So on our notes, we're going to do the different colors. On your homework, That's up to you. If it helps you, do it that way. Okay? Alright, go to the next problem. This one is a rectangular prism. Okay? So if I fold this rectangular prism back up, okay. How many sides are there on it? How many sides are on a rectangular prism? Really? 6 sides. Okay? Would everybody agree that the top and the bottom are the same? The left and the right are the same? And the front and the back are the same? And that will always be true. Okay. So when we set up the problem for a rectangular prism, that's how we're going to set it up. We're going to do top and bottom. So I'm just going to label it T/B. Front and back. So F/B. And then left and right. Okay? We just need to find all those pieces and put them together. So, pick a color. Again, I don't care what color. I'm going to start with the top and the bottom. I'm just going to draw the top. So I'm going to outline the top. In my case, I'm going to do green. What numbers would be on the top of that? Caleb? 4 and 3. I can move this 4 up here. Oh, that was a bad 4. 4 and 3. So for top and bottom, I'm going to do 4 times 3, which is 12. Well, that's only the top. If I need the bottom also, what do I have to do with that number? Krista? Times it by 2 because I need the top and the bottom. So I'm going to times this by 2. 12 times 2 is 24. Okay, that's the top and the bottom. Then let's do the front and the back. So grab a color and outline the front. Okay, what are the numbers on the front? Tyler? 4 and 8. So the front and back is 4 times 8, which is 32. That 32 is just the front. We also need the back, so what do I have to do? Really? Multiply by 2. So 32 times 2 is 64. Okay, then I've got to do the left and the right. I'm going to outline the right side here. What numbers are on the right side of that figure? Okay. 8 and 3. 8 times 3 is 24. That's only the right, so we also need the left. So we're going to multiply by 2, and we get 48. Okay, last step is to add all of that together. 24 plus 64 plus 48. What do you get? 136 inches squared. Okay? I think the hardest part is figuring out what numbers go where. Okay? And that's why outlining it and tracing it will be helpful. Okay, flip the page. Okay, this one's a triangular prism again. Okay, so we have to do triangles times 2. We have to do rectangle 1, rectangle 2, and rectangle 3. Okay, so if it helps you, grab a color and outline the triangle. If I only had to look at that pink triangle, what numbers are on that triangle? Tyler? 6 and 7. The 6 should be so 6 times 7 divided by 2. 42 divided by 2 is 21. That's only one of the triangles, so then I have to times by 2. So 21 times 2 is 42. Okay, I'm going to start with the bottom rectangle. What are the numbers on the bottom? Savannah? 7 and 10. So 7 times 10 is 70. Okay. I'm going to pick this back one right here. What are the measurements on that rectangle? 7 times 10 again is 70. And then the last one would be this rectangle right here. Which is what? 7 times 10. They were all the same. This triangle was 7, 7, 7. So, okay, last step is to add it all together. So 70 times 3 is 210, plus we'll write 252. Would you agree? So 252 centimeters squared. Question so far? That's a lot of work. There's a lot of steps to it, right? It's not really that hard, there's just a lot of steps. Okay, then let's look at just these couple word problems. Because the word problems are going to get some of you. Okay? So all outer surfaces of a box are covered with gold foil except the bottom. What are some reasons why you wouldn't cover the bottom of a box? Like imagine wrapping a box. I've done this before. Where I haven't wrapped the bottom. Wanna know why? Because I ran out of wrapping paper. Who looks at the bottom? As long as you have enough to cover the sides and the top, you're good. It sits on the bottom anyway. So you just don't cover the bottom. That's okay. Or if it's too heavy. Nobody sees the bottom. It's too heavy to lift, maybe. Okay? So you just don't cover the bottom. Nobody's ever done that?
No. Yeah.
I've done that. Or then I have to find other random wrapping paper, but you put the random wrapping paper on the bottom because nobody's going to see it anyway. You put the nice stuff on the other side.
You just gotta like fold it over a little bit.
Yeah, just a little tiny bit so they don't notice. Okay. So this particular box measures 6 inches long, 4 inches wide, and 3 inches high. Okay. So there's a picture for you. It's 6 inches long, 4 inches wide, and 3 inches tall. How much gold foil is used? Okay, now, typically when we set this up, we have to do top and bottom, front and back, left and right. Are we covering all 6 surfaces? No, which one am I going to get rid of? Just the bottom. I don't want this piece. I'm going to cross off the B. I only want the top. Okay, so let's start with the top. I'm going to outline it in purple here. Okay, the top of that box measures what by what? 6 times 4 is 24. Do I have to multiply that by 2? No, because we don't want the bottom. We only want the top. So we leave it at 24. Okay. Are we doing both the front and the back?
Yes.
Yep, that we are. So we need both of those. Okay, so the front, can't write anymore. What happened? Free day. No. It's like not working at all. Can't even. Oh, yeah, it's spinning. See that? Okay, so this. Yes, it works. Okay, so we'd have 6 times 4 is 24, and then I have to multiply that by 2 because I want the front and the back. So 48. Okay, then the last one is the left and the right. The left and the right is 3 times 4, 12 times 2, 24. Finally, add these all together. 24 plus 24 plus 48. Matthew?
So for the front and back one, it would be 6 times 3.
Oh, you're right. Did I do that wrong? You're
Yeah,
right.
it is.
6 times 3, sorry, 18 times 2.
Oh my god.
Sorry about that. You're right.
Yeah.
See, I got so flustered because my board wasn't working. I knew that. I just tried to see if you guys would catch my mistake. Yeah, you guys are right. Okay, so 24, 36, and 24, you get what? Go ahead, Caleb.
84 because I'm sure how it works.
Okay, 84. Everybody agree? 84 inches squared. Thank you, Matthew, for catching my mistake. Okay, if we're not covering the bottom, that's what we would have. Okay, last one.
Oh, no, it's wrong.
All outer surfaces of a box are covered with leather except the top and the bottom. Okay, the box measures 5 inches long, 3 inches wide, and 2 inches high. How much leather is used? Okay, if they don't give you a picture, we kind of need a picture. We do better with pictures. So, we're going to draw it. We need a rectangle. I'm going to draw my 3 lines and connect them. Do your best. Doesn't have to be perfect, right? Just kind of has to look like a box. Doesn't have to be perfect. TJ had a whole bunch of boxes drawn on the board today. He wanted to go on the boat. I said they have to be. It was a disaster. Okay, so it's 5 inches long, 3 inches wide, and 2 inches high. So that's how I would label it. 5, 3, and 2. Okay, so typically we would do top and bottom, front and back, left and right. Do we need all of those parts?
No.
No, which ones don't we need? Caleb.
Top and bottom.
Yeah, we don't need it. It says all of the surfaces except the top and bottom. So this time I'm going to get rid of the top and bottom altogether. I'm going to cross that piece off. We're not using top and bottom. So I'm going to start with the front and the back. I'll do my measurements right this time. Or I'll ask you guys. What are the measurements on the front and the back? Tyler. 5 times 2. 5 times 2 is 10. That's just the front. We also need the back, so times that by 2. We got 20. Okay, the left and the right. What numbers are on the right? Tyler? 3 times 2, which is 6. We have to double that because we need the other side also. So that's 12. Add those together. 20 plus 12 is 32 inches squared. Okay? Questions?